All right, now we're going to talk about, there's two more types of asymptotes. One of them is called the horizontal asymptote, and that's what we're going to talk about in this particular section. There's another one called the slant asymptote, and we'll get to that one in a little bit. But the horizontal asymptote is probably the most involved. It's got three different possibilities of what you're looking for, and it really comes down to do you understand how fractions work? So let's talk about the fractional portion real quick, and hopefully that'll make the rest of this make sense. If I have a fraction, whatever the fraction is, like let's say that we're going to start off with the fraction 1/2. And then maybe I was to add 1 to the denominator. It becomes a third. Then I add 1 to the denominator again. It becomes a fourth, then a fifth, then a sixth, and so on. What you should notice is as my denominator is tending to get bigger and bigger, the numerator is staying the same, or relatively the same. The denominator is getting bigger and bigger, and if you guys remember, as the denominator of a fraction gets bigger, the fraction itself gets smaller. So a bigger denominator typically means a smaller fraction. And as a matter of fact, this thing, as the denominator keeps getting bigger and bigger and bigger, as long as that numerator is not changing at the same rate that the denominator is, and in this case our numerator isn't changing at all, this is going to tend towards 0. It's going to start to approach 0. So, eventually as you get out to 1 over a billion, 1 over a trillion, 1 over whatever the numbers are that just keep getting bigger and bigger in the denominator, it's going to approach 0. It won't actually get there, but it will approach 0. Okay? Let's change that. Let's flip it over. Let's do, and instead of using 1 in the denominator, I'm going to use 2 in the denominator. So let's say I start off with 3 halves. Then I go to 4 halves. Oops, 4 halves. Then I go to 5 halves, 6 halves, 7 halves. Well, if I keep adding halves of something, and basically my numbers here are just going to keep getting bigger and bigger, because 3 halves is 1 1/2, 4 halves is 2, 5 halves is 2 1/2, then 3, then 3 1/2, then it would be 4, then 4 1/2. As you can see, the overall number just keeps getting bigger and bigger. So what that's telling me is that if the numerator of this fraction grows faster than the denominator does, and it certainly does here, this is just going to keep getting bigger and bigger. It's going to go off to infinity. It's just going to keep getting bigger and bigger and bigger as these numbers on the top start to get extremely large. It's only when we have the top and the bottom at relatively the same rate that I'm not going to illustrate this one using fractions, that it's going to create something that we have to talk about. So that's the general concept for fractions. Now let's take a look at what that means as far as finding horizontal asymptotes of rational functions. If I were to have a function, for example, let's do 4x over 2x squared plus 1. What I want you to look at, we'll call this f of x, what I want you to look at is the degree of the numerator and the degree of the denominator. Well, the degree of the numerator here, it's not written up there, but right there would typically be where your power is. Well, the power there is assumed to be a 1 because it's not there. So the degree of the numerator, the degree of, we'll call the numerator capital N, is 1. The degree of the denominator is the highest powered exponent in the denominator, which is right there. So the degree of the denominator, we'll call that capital D, is 2. Which means that the denominator has a higher degree than the numerator does. In this case, that means that as x's get really, really big, as these x values start to get really large, the denominator is going to have much, much, much bigger values than the numerator. Now this is where conceptually this is a little bit more challenging, because we have to think in terms of concept of not as if I plug in 1 and 10 and 100. Those are relatively small numbers in the grand scheme of infinite values. We have to start thinking of these as what happens as x gets so extremely large we can't even fathom how big x can get. Basically, how far to the right on the number line we can possibly go. Well, as that happens, the degree of the denominator, because it's bigger, is going to grow so much faster than the numerator does that it's almost like the numerator is sitting still. It's not, it's moving, but it's going to seem like it as these numbers get so astronomically big. So what that means is any time that the degree of the denominator is bigger, the denominator grows at a faster rate, which means, just like in our first example that we did up here, where the denominator was growing right here faster than the numerator, this is going to tend towards 0. So we will have a horizontal asymptote here of y equals 0. And that's because this is going to approach the x-axis. The y values are going to get so incredibly small, it's going to go towards 0. All right, let's look at a second example. Whoops. I don't know what happened there. Oh, I'm writing in the wrong tool. Try that again. All right, our second example, we'll do g of x equals 4x cubed over 2x squared plus 1. So what I want you to focus on here, once again, is the degrees of the numerator and the denominator. Up here, the degree of the numerator, the degree of n, is 3. And the degree of the denominator here is 2, as you can see right there. So in this case, the numerator is growing faster than the denominator is, which means that now the top of the fraction is going to get bigger and bigger and bigger while the denominator stays relatively small. It's going to keep growing, but it's going to stay relatively small. And again, this is as x values get so incredibly large that we can't even conceive of how big they really are. It's basically going to seem like the denominator is sitting still compared to the numerator. And as that happens in our fractions, just like we did right here, and this second one, as the numerators tend to get large, as the denominators basically don't, this thing goes off towards infinity. And that is what's going to happen in this particular example. So the horizontal asymptote here, well, there isn't one. I'm not approaching any y value. These y values just keep getting bigger and bigger. So we actually say that there are no horizontal asymptotes for this one right here. Okay, then there's one more example we're going to do. And this one is, we'll call this h of, it's twice now I've done that. All right, we're going to call this one h of x. And this is going to be 4x squared over 2x squared plus 1. So once again, the first thing we're going to do is we're going to compare the degree of the numerator, which is degree of the numerator, which is 2, and the degree of the denominator, which is also 2. All right. What you can see is now these two things are the same. When this happens, what that's saying is that basically the numerator and the denominator are growing at almost exactly the same rate. And the way we can actually find the horizontal asymptote here is when they are growing at the same rate, you look at the leading coefficients, which in this case is 4 and 2, and you divide them. Whatever you get from that division is what y will approach. So we would say our horizontal asymptote here is y equals 4 over 2, which reduces to 2. So let's go ahead and recap. You have three things to look for here when we're talking about horizontal asymptotes. To find a horizontal asymptote, if the degree of the numerator is greater than the denominator. So the top is going to grow faster than the bottom. That means the fraction keeps getting bigger and bigger and bigger. That means that your horizontal asymptotes will not exist. You have no horizontal asymptotes. It will never approach a horizontal value. It will never approach a y value. If the degree of the denominator is bigger than the numerator, so now the bottom is growing faster than the top, anytime the bottom of a rational function grows faster than the top, you are going to approach 0. So it will always be y equals 0. And then the last one is, if the degree of the denominator equals the degree of the numerator, then what you do is you divide the leading coefficients. So it would be y equals the division of the leading coefficients. So those are your 3 potential horizontal asymptotes. Now, one other thing that we will have to discuss in the future is that horizontal asymptotes do not work exactly like a vertical asymptote in the fact that you can actually cross a horizontal asymptote, because the idea is that a horizontal asymptote is what really happens as x's get really large in either direction, so either towards infinity or negative infinity. It's not so much what happens in the middle of the graph, like somewhere around 0, 1, 2, 10, whatever. It's not necessarily going to be that. So horizontal asymptotes can be crossed in the center of a graph, but as they start to go off towards the extremes, they will not be able to be crossed. All right, so that's the idea about horizontal asymptotes. Excuse me. We're going to start putting all this together in just a few minutes to actually show how to graph it. But the last thing I'm going to talk about with you guys is going to be the slant asymptote.